Okay, we're going to talk about 15.6 today, which is permutations. Now, there's two things that we deal with that are similar, and it's called permutations and combinations. Today we're going to talk about permutations. And permutations, the key is with permutations, order matters. So, order matters. Write that down. Order matters with a permutation. With a combination, order doesn't matter. Okay, we'll talk about that in 15.7, but with a permutation, order matters. Now, there is a notation on the calculator, or a function on the calculator that I should address. And what that function is, okay, the function is called factorial. Okay, factorial is found on the calculator. It's an exclamation mark. And what the factorial button does is, factorial is a way to multiply. So if I have 5 factorial, that's equal to its multiplication of the number plus, or not plus, but times all its preceding numbers. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Now, on your calculator, you could go 5 times 4 times 3 times 2 times 1, hit enter, and you get 120. Okay, and I think you can see that. Okay, yeah, you can see that. So that seems a little laborious, especially when you do something like 10 factorial. Do I really want to go 10 times 9 times 9, 8 times 7, etc.? No. So what I can do is I can go 10, and then on your calculator you're going to need to find the button. These ones, it's the PRB button for probability. And under this one, it's the number 3, the exclamation mark right there. 10 factorial gives you 3, 6, 2, 8, 8, 0, 0. So 3,628,800. So the PRB button. Now, on the graphing calculators, which some of you have, the TI-84 Plus, okay, you're going to find that 10, you're going to find it underneath math. So you go to your math function right here, math button, and then you're going to go all the way over to PRB, and then under PRB, it's the exclamation mark 4. Now, also we're going to use this function again, the factorial button, but also there's some other stuff in there. You'll want to go right back to the same thing, so you get the same answer. So PRB and math, keep those in mind. Now on another calculator, you have to find out where that's at if you're not seeing, if you don't have these two calculators. Okay, now a permutation is, you can think of it this way, okay? If order matters, okay, let's think of an example where order matters. How many different ways can you rearrange the letters of John? Okay. So how many ways can you rearrange or arrange letters of John? Okay, now with that, we could say, okay, well, we could say I could go John, so that's one way. Or I could go Jhon, or I could go Jhno, or I could go Jnho, or Jnoh, or Jonh, right? Haven't done that one yet. And I think that's it. I could have done the O up there, John, then Jonh. So what I realize is there's 6 of those, okay? And then if I use the letter O first, it would be O, J, H, N, O, J, N, H, O, N, J, H, O, N, H, J, O, N, no, we already did that. Sorry, getting a call from my mom. Hey, Mom. Yes, she was. He is doing copies. Okay, bye, love you. Okay, sorry about that. Trying to hunt down a student who's lost. Okay, so 1, 2, 3, 4, 5, 6. I'm not going to go through all of them because the next one we could do is H, with 6 of them, and then N with 6 of them. What we're seeing though is the order matters, right? J-O-H-N is one word, and even though these aren't words, it's a different arrangement. It looks different, it's something different. J-H-O-N. It looks different because we're saying the order matters. Okay, the order matters. So with that being said, there is 6, 6, 6, 6, giving you a total of 24. Well, another way we could have done that is to say, well, if I use a J in the first spot, well, not a J, we could have done it like this and said, well, how many letters are there that I could put in this first spot? Well, if I pick J, or O, or H, or N, there's 4 different letters that can go in the first spot. J, then O, then H, then N. There's 4 different letters. But as soon as I choose the letter J, okay, there's how many letters that I can mess with? Well, there's only 3 letters. Or as soon as I pick the letter O, there's how many letters? 3 letters. And then as soon as I pick the second letter, there's how many letters left? 2. As soon as I picked O and J, there'd only be 2 letters left. So 2. And then as soon as I knocked out that, there'd be only 1 letter left that I could choose. And that would be 1. So 4 times 3 times 2 times 1. Isn't that factorial? 4 factorial? Sure. And that's 24. So you could either do 4 factorial on your calculator, or you could do 4 times 3 times 2 times 1. Now, that is what we call a permutation when you say, hey, how many different ways can you rearrange the letters? Now, these aren't words, but they're different arrangements of the letters. That's called a permutation. Now, a permutation by definition, okay, a permutation by definition, you can actually write like this. It's N, P, R equals N factorial over N minus R factorial. Now, what this is stating then is the number of things you have and how many ways you want to choose them. Okay, so this is the number of things you have, and this is the number of ways, or the number of things that you're going to choose. Okay, so the number of things you have, the number of things you're going to choose. Okay, so in the case of what we just did, we had 4 letters. We wanted to choose 4 of them. So we could say 4 factorial over 4 minus 4 factorial, which is equal to 4 factorial over 0 factorial. Now, this is going to raise an interesting issue. I'm referring to the letters of John, by the way, saying there was 4 letters. We wanted to choose 4 of them. So that's why it's 4, choose 4 with a permutation. So 4 factorial over what we see is 0 factorial just by plugging into this formula. Now, with that, what we're going to notice is we know what 4 factorial is, 24. Well, what's 0 factorial? It seems like it would be 0, but 0 factorial is actually equal to 1. So in this case, it would just be 4 factorial, which is just equal to 24. Okay? So you can do that, no problem. Or there's another way to do it just on your calculator with 4p4. And you might have seen that with the probability. So what I'm going to do is I'm going to hit 4, and then I'm going to go to Math, or under your probability button if you have this one. Let me do this, 4 probability. And you're going to see I got to get over to probability on here. You're going to see NPR here, and you're going to see NPR there. Hit enter, okay? And, whoops, I hit the wrong one on this calculator. And then you're going to hit 4 again. And then you'll hit enter, and you'll hit enter. And it gives you 24, okay? So you can use the NPR button. You actually don't have to plug into the longhand form right there. You can just plug into the NPR button. Okay, let's take a look at some examples here. If I had, let me think here. Okay, let's do this. Let's go to page 737, number 10. Number 10, in how many ways can 8 people be lined up in a row for a photograph? So you have 8 people, and you're going to line them up in a row for a photograph. Now, if you think about it, it does matter in a photograph. It makes the photo different if person A is standing next to B as opposed to person A standing next to C. Okay, now they all will be in the picture, but it would look different. So how many different ways can you arrange them? So there's 2 ways to do this. One is to say, okay, I have 8 spots, 4, 5, 6, 7, 8. In the very first spot that I'm going to choose, I'm staring at 8 people and I'm saying, okay, I need to choose one of you, but I have 8 different choices. So there's 8 different people. As soon as I choose one of them, how many people are left to choose from? There are 7. And then as soon as I've chosen 2 people, there's 6 people left, and we go on down the line. So that's one way to do this. This is the same thing as 8 factorial, which is equal to something. We can also say it's the same thing as saying 8 permutation 8. Those should all equal the same thing. So if we do 8 factorial or 8 permutation 8, I'll do both on here. 8 factorial, and then I'm going to do 8 permutation 8. You should get the same answer, 40,320. So either way is acceptable to do. Okay, now we've noticed that there's 8 people. We chose 8 of them, so 8 permutation 8. Is there another type of problem that will yield something different besides 8 permutation 8? Like it may be 8 permutation 2 or something like that. Let's check and see if we can find a different problem that will yield something a little bit different for us. What if I take a look at number 14 on page 737, number 14. Number 14 states for us, it says, in how many ways can the letters of the word today be arranged using only 3 of the letters at a time? So you want to rearrange the word today, which there's 5 letters in today, right? Today. There's a total of 5 letters. And we are going to choose 3 of them. Okay? So there are a couple ways to do this. Let's think of it in terms of our P button, the NPR button. Okay, so you have N, do it right up here, NPR. You have 5 letters, that would be in for the N. You have 5 things permuted 3 ways, because we're going to choose 3 of them. So 5, choose 3. And let's see what that gives us. Go ahead and do that on your calculator. And you end up with 60. Now, the other way you could have done that is you could have said, well, I'm going to choose 3, so there's 3 spots. You could have said in the very first spot, okay, I have how many letters to choose from? I could choose a T, a T, an O, a D, an A, or a Y, so there's 5 things. As soon as I've chosen one of them, there's 4 left, and as soon as I've chosen another one of those, there's only 3 left, and that's all I'm going to choose is 3. Well, 5 times 4 is 20. 20 times 3 is equal to 60. Our counting principle comes into play there too. We can do the same thing. Okay, let's take a look at number 20. Okay, on number 20, it says, find the number of ways the letters of each word can be arranged. The letter we're using is Albuquerque. A-L-B-U-Q-U-E-R-Q-U-E. So here's the word Albuquerque. Now, what's interesting about this is we see some repetition, don't we? We see, well, there's only one A, one L, one B, but do I see, how many U's do I see? A U here, a U here, and a U here, right? And then I see a Q and I see a Q, I see an E and I see an E, and then R is by itself. So when I think about that, if I change this U for this U, you're going to have the exact same word. Or if I change this U for this U, you're going to have the exact same word. So you're actually not going to get anything different, okay, by switching those U's out. So we actually don't have, if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters, right, that we're counting. There's 11 letters. Okay. But with the repetition, we actually aren't going to be able to use all of them. So here's what we do with repetition. And it's in your gray box on page 736. The gray box on page 736, just scan over there, it says, if a set of n elements has n sub 1 elements of one kind alike, n2 of another kind alike, and so on, then the number of permutations p of the n elements taken n at a time is given by, and they give you this formula. What the formula states is that the permutations, the arrangements that I want to use, I take the 11 letters, so 11 factorial, but we know that's not true. We can't just say 11 factorial because there's repetition of the U's and the Q's and the E's. And you need to divide that, okay, 11 factorial needs to be divided by the repetition ones. So when I look at the U's, there's 3 U's, so 3 factorial. So I've taken care of the U's. And the E's, there's 2 of them, so 2 factorial for the E's. And then the Q's, there's 2 factorial for the Q's. So I knock those out. Okay, the other ones don't have any repetition. You could say 1 factorial, but 1 factorial is just 1, so that wouldn't make any sense, or it wouldn't help us. So we do 11 factorial, so go ahead and do that. 11 factorial divided by 3 factorial times 2 factorial times 2 factorial. And we end up with, and 2 factorial, by the way, is just 2. You should have gotten 1663200. Okay, on that one. Now, let's do one more. The next one we do, let's do 24. Let's do 24. In how many ways can 3 red, 4 blue, and 2 green pens be distributed to 9 students seated in a row if each student receives 1 pen? So there's 3 red, there are 4 blue, and there are 2 green, and there is a total of 9 students. Okay, so on this one, okay, if we look at this, we say, all right, well, the red, let's assume the pens are the same, right? 3 red pens, okay? So if you get the first red pen, Say, okay, I got red pen number 1. Well, that's the same as getting red pen number 2 or red pen number 3. So you can think about it is that 9 students are going to receive pens, but there's repetition in what they're going to receive. And so you're not going to get 9 times 8 times 7 times 6, so on and so forth. This is another repetition one of 9 factorial, the total number of students, and then you're going to get the 3 factorial, 4 factorial, and then the 2 factorial, representing the 3 red, 4 blue, 2 green. And so we go ahead and do that on our calculator and see what we get. 9 factorial divided by 3 factorial. And you can do it all in parentheses, so you can do it all in one fell swoop rather than having to. And then you don't really need to do 2 factorial because 2 factorial is just 2. And we get 1,260. Okay, and thus concludes then 15-6.